What makes flu strains change so quickly? Imagine a virus that's constantly on the move, changing its appearance so it can hide from our immune system and keep infecting new people. That's exactly what influenza viruses do. They change rapidly because they have a high mutation rate and a special ability called genetic reassortment. These two features work together to help the virus evolve fast and stay one step ahead of our defenses. Influenza viruses are made of RNA, which is a type of genetic material. When they replicate inside our cells, their copying process isn't very precise. The enzyme that copies their RNA makes mistakes quite often, leading to tiny changes called mutations. These mutations happen at a rate estimated between 2 and 4.5 times 10 to the minus 5 substitutions per nucleotide for each copying cycle. That might sound small, but it adds up quickly. Inside an infected person, this creates a diverse mix of virus variants, some of which might be better at avoiding our immune responses or resisting antiviral medicines. Most mutations are harmful to the virus, but because of the high number of errors, some can give the virus new advantages. The virus's ability to tolerate these small changes without losing its ability to infect is called mutational robustness. But mutation isn't the only way influenza viruses change. They also undergo a process called reassortment. Since their genetic material is segmented into different parts, when two different strains infect the same cell, they can swap segments. This mixing and matching can produce entirely new combinations of surface proteins and internal genes very quickly. These new combinations can make the virus look different to our immune system and sometimes lead to the emergence of a novel strain that can cause a new flu outbreak. Influenza viruses tend to evolve faster than influenza B viruses. This is partly because they mutate more quickly and face stronger immune pressure from humans. Influenza changes at about 2.6 times 10 to the minus 3 substitutions per site each year, while influenza B evolves more slowly at about half a times 10 to the minus 3. Within a single person, the virus starts with low diversity but accumulates mutations over about 5 to 6 days. Children's viruses tend to mutate a bit faster than adults, and some subtypes like H1N1PDM09 tend to change more quickly than others. All these mechanisms, high mutation rates, reassortment, immune pressure, and the virus's ability to tolerate changes, combine to make influenza viruses very adaptable. That's why flu strains can change so quickly, making it necessary for scientists to constantly monitor and update flu vaccines. It's a fascinating and complex process that keeps the flu virus one step ahead, reminding us of the importance of vaccination and ongoing surveillance. If you want to stay protected, always follow health authority advice and consult healthcare professionals for personalized guidance.